Hey everyone, welcome back. In this video, we are going to solve an interview coding question. It was actually asked by Amazon in one of its interview. So without any further ado, let's hop in. So the question is on a rotate array. So what is the question? Let me just read it out quickly. Given an unsorted array of size n, rotate it by d elements anti-clockwise. Now what does this mean is, it is pretty simple. Let's just consider this array. We have this array 1, 2, 3, 4, 5. Now rotating an array anti-clockwise simply means shifting the elements to left. Okay, we know that what is anti-clockwise, right? So if this is an array given to us, just shift the elements with the required value that you have specified. As they have said, they will specify a d that will represent the degree of rotation. So let's just say we have this array 1, 2, 3, 4, 5 and we have some d value equals to 2. So what does this simply mean is, as they have told here, anti-clockwise, simply shift every element to the left by 2 units. That simply means this 3 will come to this 1's position. This 4 will come to this 2's position. This 5 will actually come to this 3rd position. And what will happen with this 1 and 2? Simply 1 will shift back here. So it will be more clear. Let me just take d value 1, so it will make things simpler. That simply means shift every element to the left by 1 unit. So what will happen to this 1? This 1 will actually go to this 5's position. This 5 will move to this 4th position. Okay, let me just quickly write it. So the 2 will come to 1st position, 3 will take 2's position, 4 will take 3's position, and 5 will take 4's position. And 1, as we know, it shifts, it actually rotates back to the last position. Okay, so it's fairly simple. So if d equals to 2, again we have to perform one rotation. Okay, so if d is equals to, let me just write it again. Let's just say after this one rotation, we again performed a rotation by 1 anti-clockwise. Again performed one anti-clockwise rotation. Again every element will shift to the left by 1 unit. So this 2 will actually go to the last position, but 3 will take 2's position, 4 will take 3's position, 5 will take 4's position, 1 will take 5's position, and 2 will be rotated back to the last position. Okay, so the question is fairly simple. Okay, so there's the description of input given. First line will contain the t denoting number of test cases. Pretty simple. The first line of each test case contains two space separated elements, n denoting the size of array and d denoting the number size of the rotation. Okay, so it's not much of a big deal. First they will say they will give the input to the number of test cases, then the next line, next t lines will actually contain n, d and so on. It will be simple. I'll just show you in just a bit. Okay, don't worry. The output, they are just expecting the rotated array. So let's just examine this sample input. Okay, so what does this sample input says? Let's just say this 2 actually represents number of test cases. Not much of a big deal. This phi 2 simply represents, phi represents the size of the first array and 2 is the degree of rotation. Okay, so this then they will enter the array. So this 1, 2, 3, 4, 5. Okay, and there is the next array specified here. So what does this 1, 2, 3, 5 become after 2 rotation? We just did it, right? After 1 rotation it will become 2, 3, 4, 5, 1. After second rotation it will be 3, 4, 5, 1, 2. So that is the output here. If you see, output of the first array is 3, 4, 5, 1, 2. So you got the logic, right? So let me just quickly take the input, then we will see how we can actually implement this logic. Okay, let me just take the input of t, the number of test cases, c in t. Okay, then I'll run a while loop, exactly t number of times, because after every iteration this t will be decremented, because we know this post decrement. Okay, that's not what I'm doing here. Okay, what does this say? First line of each test case actually contains two space separated elements n and d. Okay, so we have to create two new variables here then. Int n, that represents size of array, and this d, I'll name it more appropriately. I'll name it something like this. Okay, so that's more clear to you. Size and degree. Okay, so short for degree of rotation. Okay, let's just take the input then. In size, in degree. Okay, so first we take the number of test cases, then we'll run a loop accelerating t number of times. We take the input of size and degree. Okay, then we have to take the input of the array, right? So let me just create an array with the required size. Let's just take the input of the array then. Int I equals to 0, I is not a size, I. So the next thing I have to do, I have to actually print the rotated array, right? So for printing the rotated array, I will write a function here. So the function will be named print rotated. Okay, very appropriate name. What it will take, it will simply take our original array, it will take size of our array, and of course the degree. Okay, will be a void function, and it will actually print the rotated array as they have specified here. Okay, it's pretty simple. So let's just write this print rotated then. So it will be a void function because it doesn't return anything, it just prints. So print rotated print star array. Okay, because first input is the array, and in size and in degree. So we know the logic. What you have to do, we have to actually perform left rotation. That is, you have to shift the elements to the left equal to d number of times. So if d is 2, we have to shift elements 2 times to the left. If d is 3, we have to shift elements 3 times to the left. Okay, so the logic is simple. So now the question arises, how do we achieve that? Now, in order to understand the implementation, let me just give you a quick example what we are going to perform internally. Okay, so let's consider we have an array of size 5. Okay, and we have to perform a degree 2 rotation. That is, we have to shift every element to the left 2 times. Okay, so this 3 will come to this first position, this 4 will come to this 2's position, this 5 will come to this 3's position. You know that, right? We just saw that. This is the most generic way of writing indexes, right? We write the first element as 0th index, second element as first index, third as second index, and similarly. But there is one more way of representing indexes. And what is that? That is the negative index. And what is that? It's very simple. The last element is said to be at index -1. Similarly, the second last element is said to be at index -2. Similarly, third last element is said to be considered at -3. And similarly, this 2 will be at -4. The first element, if you see, will be at -n position and being the size of the array. So what we discussed, we generally use zero-based indexing to represent our elements, but we can use negative indexing also to represent our elements. And how does negative indexing work? Simply, the last element is said to be at -1 and the first element is said to be at -n. That is, n is the size, n being size of the array. And similarly, these middle elements are represented like that. Immediately you may ask, why am I discussing this negative index? You will understand in just a bit. Basically, when we are performing rotation, okay, so we are performing rotation and we are shifting every element to the left. Let me just show you the rotated array, how it looks. So if you see here, the index of the positions changed, right? Clearly it changed. Now there is actually a proper formula how this index is changed. And what is that formula? Let me just show you the formula and then we will go through it. So this is the formula. The new index of the element is equal to original index minus the degree of rotation. And how did this formula come? It's very simple. It's just a normal common sense how this formula came. Let me just examine for index values. Okay, let's just say the index is let's say 5. Okay, so index is 4. So we are talking about 5. Okay, so index is 4. So what will be its new index? Let me just represent it like this. New index. What will be it? It will be original index. What is the original index? 4 minus degree of rotation. Degree of rotation is 2. Okay, so it will give to 2. So we clearly saw that 5's new index is 2, and it's true. Let me take another example. Index equals to 3. Okay, so I'm talking about this 4 here. So what will be its new index? Original index, that was 3 minus d, because degree of rotation is 2, right? So 3 minus 2 equals to 1. So this clearly makes sense. But immediately I see you ask, what about this 2 and 1? Because when I do 1 minus 2, it will become -1. That's why I discussed the negative indexing. When I perform for this 2, so this is a special case, right? For index 2, let's just say for 1. Okay, for index 1, that is the position of this 2. What will be the new index? It will be 1 minus 2, and it will be -1. But if you see, it's indeed true. This 2's new position is -1. Let me just count out for the first element also. Its index will be 0. So new index will be 0 minus 2. 0 minus 2 is -2. And indeed, its position is -2. But if you want to represent this -2, we cannot write simply array of -2, right? So we have to write this 3. And how did this 3 came actually? If you see, I've not done much here. I've just added the size of the array to it, right? So this -1 actually, let me write it here only. This -1 is actually equal to 5, that is size of array, plus -1. If I do 5 plus -1, I actually get this 4, right? So I'm not saying f -1 equals to 5 plus -1, but I'm saying is this -1 actually simply implies it's the 4th index, because if I add the size of array plus that particular negative index, I get the positive index value. If it's not clear, let's just take this another example. This -2 actually represents 3. And how is that? Let me write it here only. So when I actually add this -2 with the size of the array, that is 5, okay? When I actually add this 5 plus -2, this 5 plus -2 will actually become 3, right? So the logic is very simple. The new index is simply equal to original index minus degree of rotation. We saw, right? Okay, so this was the original index 4. What was the degree? The degree was 2. So the new index will be 4 minus 2 plus 2. But there may be a chance that this subtraction may give to negative indexing. So it's very simple to convert this negative index to positive indexing. Just add the size of the array. So I hope it's clear, right? Let me just quickly summarize what we discussed here. We have an array, okay? Its size is n, and there will be a degree. For example, you have taken size 5 and degree 2. We have to perform rotation. What does rotation mean? Simply shift element, and the rotation is anti-clockwise. Okay, one more thing. You have to simply shift all the elements to the left equal to this rotation. Then we saw how the negative index are represented. Okay. Then we saw the formula. The formula was pretty simple. We have to just subtract the degree from its original index because we want to move to the left. Now, if the question was about clockwise, we simply had to add it. But we found out that there may be a chance when we subtract it for left rotation, it may give rise to this negative indexing. But if we are writing code in C or C++, we cannot simply assign array of -1. So what we did is we have to actually find out the positive counterpart of that negative index. It was fairly simple. Just add the size of the array to it. Now, as you understood the logic, it will be very easy for us to code this logic. So what we have to do, first things first, we have to actually create the rotated array, right? Because we have to actually print it. So I'm just creating, name will be rotated and size is size. Okay, we will print it in this function only. Okay, and what we will do, we will actually run a for loop through this array, right? We have to actually find a position of each and every element and assign it into this new rotated array. It will be clear in just a bit. Okay, so we have to run this for loop. Of course, size number of times, index starts from 0. What do we have to do? At every iteration, we have to actually find the new position of that element, right? So we'll simply declare, let me just declare a position variable outside here. Let me just declare it here in pose. Okay, simple. At every iteration, we will actually find the position of that particular member. Let me write a comment here. We know that new index is equal to original index minus degree, right? So that every iteration, the position will be original index. What is the original index? Index minus degree. Now, before actually storing into the rotated array, we have to check if this position is smaller than 0 or not. Because if it is smaller than 0, we have to actually convert it into its a positive counterpart, right? So if it's smaller than 0, what we have to do? We have to simply add position. We have to simply add the size of the array to this position. Okay, so if it becomes -1, we will add size of the array, that is, for example, the array is 5. So it will be simply equal to the last index. So we already discussed it, right? We have to just add this as the array to get its positive counterpart. And then lastly, we will just assign it to its specified position. What will assign it? We will simply assign that element. This array of index is actually the element at that position, and we'll assign it to its new position in this rotated array. Okay, because this pose will represent a new position. Lastly, print this rotated. Okay, let me just write in the for loop here for in, and we require spaces after every element, right? So I'll just add some spaces here, and after printing every element, I'll just simply add a new line here. Okay, I'll just add using printf. Okay, I'll just add a new line here so that after every array there is a new line. So fair enough. What we did, we iterated through every element, find its required position. But if its required position is a negative index, then we converted it into its positive counterpart, and then we updated the rotated array. And then in this for loop, we'll actually print the rotated array. Makes sense? And I'm just printing the new line here. So then, let me just compile and test the program. Okay, let's just see what happened here. We have 1, 2, 3, 4, 5. And indeed, we got 3, 4, 5, 1. 3, 4, 5, 1, 2. And similarly, this is also valid output. Let me just submit it and see if we get the valid output. Perfect. It executed completely fine in 0.63 seconds. It's a pretty fast time. So finally, what we did, we simply here took the required input and then we performed the rotation here. And what was the logic behind the rotation? Simply shift the elements to the left equal to the required specified degree. And how did we do that? There was a simple formula. The new index was actually found out by subtracting the degree from its original index. But if the new index resulted into its negative index, then we need to convert it into positive counterpart. That we did here. And after getting the position, we simply updated in this rotated array and we printed out the rotated array. So I guess that's it done. Thank you for watching. Leave a like if you learned something new.